Dear ladies and gentlemen, my name is Fryz, and I'd like to represent you the results of our research titled as Models and Characteristics of Identification of Noise Stochastic Signals of Research Objects. Noise signals usually have a stochastic nature of formation, the dynamics of change in intensity and characteristics in space and time. Traditionally, the analysis of such signals is carried out in two directions. First of all, there are problems of detecting signals in the presence of noise, using a significant number of methods to reduce the effect of noise in order to detect signals. And also the problems in which noise signals are the subject of research, mathematical models of signals are justified, their spatial, temporal, and spectral characteristics are determined and statistically evaluated. We classify the noise signal identification methods on two approaches. First of all, the approach which is represented on the slide is when the object of study is the source of noise signal. And the second method, in which the object of study is the space-time operator of the test noise transformation. In most cases, white noise is used to identify both linear and non-linear systems. The general approach of identification of noise stochastic signals is represented on the slide. It consists of the three statements. Statement 1. The noise signal generated by the object of research is the result of the action of a large number of elementary stochastic impulse disturbances of various physical nature, including thermal, mechanical, electromagnetic, and so on. Statement 2. Identification and determination of the state of the research object is based on the use of a mathematical model of the set of the space-time and spectral characteristics of the generated noise signal. And finally, statement 3. In the case of the functioning of two or more objects of study in a limited area of space, the noise signals generated by them create various combinations of additive and multiplicative mixtures, which are the subject of theoretical and applied research, including the problem of detecting noise signals. The solution of various problems of studying noise signals is based on the use of mathematical models. Even though they do not reflect all the properties and characteristics of real objects, models play a fundamental role in theoretical, modeling, and experimental studies. On the slide, the schematic illustration of a formalized structure of a mathematical models of stochastic noise fields and signals is represented. According to the general approach of identification of noise stochastic signals, we developed and applied the following mathematical models and their characteristics. First of all, it is linear random process, which is defined using stochastic integral, which is represented on the slide, and is a stochastic integral of the non-random function driven by the process with independent increments, which is generating process for this example. The linear periodic random process is the particular case of the mathematical model when the kernel and the process with independent increments have the specific processes of periodicity. The linear space-time random field is defined as the field that allows the integral representation on the following form. We can see that there is integral representation of non-random kernel driven by Hilbert space-time stochastically continuous random field with independent increments. That is, linear random field is the generalization of linear random process. Conditional linear random process is defined as the stochastic integral of the random kernel driven by stochastically continuous random process with independent increments, which is generating process. The difference between conditional linear random process and linear random process is represented on this slide. The general characteristics of the developed mathematical models are characteristic functions, that is, one-dimensional and n-dimensional characteristic functions, cumulant functions, mathematical expectation, and covariance function. The expressions for that characteristic are represented in our paper. Also, that characteristics can be estimated and can be used for identification purposes. Thank you very much.